The thing we need to understand here is that to find the minimum point of a curve, at the minimum point of the curve, the gradient of the curve is 0. Now, if we've got a curve, to find the gradient of the curve, we need to find dy by dx. So the first thing I'm going to do is differentiate this expression. If I differentiate x cubed, I get 3x squared. Here I do 2 times minus 2, well that's minus 4x to the power 1, well that's just minus 4x. Differentiate minus 15x, and I get minus 15. And at a minimum, I know that dy by dx is equal to 0. And that means that 3x squared minus 4x minus 15 is equal to 0. Now we need to factorize that. So you can either do it by inspection. So it's got to be 3x there, and it's got to be x there. Two numbers that multiply to make 15. Well, I'm going to try 5 there and 3 there. Well, that gives me 5x and 9x. If I put a minus sign there and a plus there, I've now got 3x squared plus 5x minus 9x, which is minus 4x, minus 15, which is correct. You might have other ways of factorizing that, which means that there are two possible solutions to that equation. Either 3x plus 5 is equal to 0, well that means that x is equal to minus 5 thirds, or x is equal to 3. Now, they both look a bit nasty. I know from the shape of the curve looks like this, but I'm going to have a maximum and a minimum. So I can probably guess, I've got a positive cubic, which means it's going to be definitely that shape. X equals 3 is further right than x is minus 5 thirds. So the chances are that this one is going to be the minimum, but I'm just going to check. And to do that, I differentiate again. Now that gives me d2y by dx squared. If I differentiate this expression, I'm going to get 6x minus 4. So when x is equal to 3, d2y by dx squared, my second derivative, is going to be 6 times 3, well that's 18, take away 4, which is 14, and I know that if the second derivative is positive, so greater than 0, that means that I have a minimum. So in fact, my minimum, the x-coordinate of the minimum point on the curve, is just x equals 3.